good morning, good afternoon, or good evening, whichever one is applying to you. Today we're going to be talking a bit more about logic. There are two laws of logic that we're going to be going over today. There are a bunch more, but in terms of a geometry class, there's not a whole lot more we're going to go over. So today is specifically going to be the law of detachment on this video, and in another one, the law of syllogism. And that's what they call them in this setting. I will say, like, if you ever go into actual symbolic logic, they're going to be called different things. But we are going to be calling them the law of detachment and law of syllogism. And with that said, let's zoom in and start talking. So the way the law of detachment works is it says, given a conditional statement, if the hypothesis is true, then the conclusion is true. For example, if I was to say, if you eat your vegetables, then you get dessert, as soon as my son eats his vegetables, that means he has to get his dessert. It wouldn't make sense if he didn't. It would just mean I was lying. And with logic, you're assuming you're not lying. So if this whole, if you remember what we were doing before, if P then Q, if P then Q, if you eat your vegetables, then you can have dessert. What this is saying, the law of detachment, is that my son ate his vegetables, therefore he would get his dessert. So if you eat your vegetables, you get dessert. I ate my vegetables, so I get dessert. That's kind of what's going on here. Symbolic map, that just means write it all in symbols. I already did part of it up here. You start with a regular conditional statement, if P then Q. Then in a different sentence, it says, hey, guess what? P was true. Since P was true, that means Q has to be true. So you would write a line, and you would write Q. And you put 3 little dots in the form of a triangle in front. The way this reads out loud is if P then Q, P, therefore Q. This little triple dot is a therefore. That is what it means. Therefore, the triple dots in a triangle. Therefore, if P then Q, P therefore Q. So what you're going to be looking for specifically is it is going to start with an if-then statement. And what you want to make sure is that the next sentence is talking about that first part being true. If you ever say, like, if P then Q and then Q, there's nothing you can do about that. The law of detachment only works if you're saying that the first part is it. Like, if you eat your vegetables, then you get dessert. My son ate dessert. Well, that doesn't mean he ate his vegetables. Maybe he just, when I wasn't looking or I was in the bathroom or something, I know he went to get a dessert and he ate it. So saying he ate dessert doesn't guarantee he ate his vegetables. That would only be with the biconditional. You get your dessert if and only if. But that's not what this is talking about. This is just talking about a one directional. If you eat your vegetables, then you get dessert. Maybe he didn't eat his vegetables, but later on he did something very nice for his sister, and then I gave him dessert. So there's more than one way he might be able to earn that dessert or something like that. So eating a dessert does not mean he ate the vegetables. It just meant he did something to get dessert. Nothing, if you see the word nothing, that is called no valid conclusion. So at least on this piece of paper, everything is either law of detachment or it's not. So if it does look like this, you'll write yes, and then you'll say the Q part. Or if it doesn't look like this, then you're just going to write no valid conclusion. So let's see what it looks like. If Mark earns and saves $30, he can buy a new video game. Mark saves $30. So it is matching. If Mark earns $30, and then it says he does earn $30. So if he has $30, he can buy a new game. He has $30, so he can buy a new game. That's what's happening. So I'm just going to write something like that. Mark can buy a new video game. Doesn't mean he will, but he could. If you want to write the word therefore in front, you can. Doesn't matter too much, as long as it makes grammatical sense. Like if you're saying it to somebody else, it's fine. In the next one, if a quadrilateral is a rhombus, then it is also a parallelogram. So if a quadrilateral is a rhombus, I want to see if that's the same thing as the next part. A quadrilateral is a rhombus. Sure enough, they match. They are both talking about a quadrilateral being a rhombus. So, according to the law of syllogism, it is also a parallelogram. So therefore, quadrilateral is it ABCD? Yep. Is also a parallelogram. Boom, done. And you keep going, you double check them. Is this the same as that? If so, you're good to go. Is this the same as that? If so, you're ready to go. Is this the same as that? If so, you're ready to go. And you keep going. So just take a look through these. Go ahead, pause the video, take a look through them, see if you can figure them out, and then I'll go over it. So let's see how you did. If you are 18 years old, then you can register to vote. Olivia is not 18 years old. Uh-oh. This one is saying she's not 18 years old. If you are 18 years old, Olivia is not 18 years old. So these two things clash. That means this is not the law of syllogism. I'm sorry, I've been saying syllogism, haven't I? This is law of detachment. My bad. Law of detachment. If you've noticed that, and obviously you can't talk to me because I'm in a video, then kudos to you. Sorry, law of detachment. I was writing that and I'm like, wait a minute, that doesn't sound right. Law of detachment. So law of detachment. Because these do not match, you would have to write no valid conclusion. Because we're talking about something called validity. Validity is saying an argument makes sense. In terms of whether this is true or not, I think it's also not true. If you are 18 years old, then you can register to vote. We'll just say, yes, that's true. And then it says Olivia is not 18 years old. So if you're inclined to say, well, doesn't that mean she can't register to vote? Keep in mind, no, maybe Olivia's 22 years old. If she's 22 years old, she can still register to vote, you know? So there's no valid conclusion. You can only make a conclusion if she was 18 years old. For the next one, if the sum of two measures is 90 degrees, so then hopefully this says the measure, the sum is 90 degrees. So let's check if the sum of the measures of two angles is 90, this and this. Let's see, 58 plus 32. So is the sum 90? And that's just a yes, no question. Is the sum 90? So 58, yada, yada, boom, boom, equals 90 degrees. So yes, it checks out. It is saying that the sum of two angles is 90 degrees. So yes, this would be law of detachment. What does that mean? It means they are complementary. So therefore, was it angle J and angle K are complementary. And there you go. Yep, period. I was grading people's homeworks, and so many people don't capitalize letters. You guys do know that, like, when you write a sentence, the first letter is supposed to be capitalized. I feel like it's dumb for me to say, but I'm not sure a single person did that when I was grading the homework. Like, capitalized letters that should be capitalized. I don't know, whatever. Make sure you put a period. The word I is a capital I. Okay, I'm a math teacher. I have to remind myself that every now and then. Lastly, if you plan to attend prom. So if you attend to plan prom, so hopefully this thing is saying Sarah is attending to plan. If you plan to attend prom. So hopefully this is saying Sarah is attending prom. So does it? It says Sarah purchases a prom ticket. Having a prom ticket is not saying you're attending prom, right? These do not match right here. Attending prom and prom ticket, those do not match. So this is no valid conclusion. Notice I didn't even read the second part of it because it doesn't matter. For law of detachment, they have to match. If you did read it, it says then you must purchase a ticket. If you plan to attend prom, then you must purchase a ticket. Sarah purchases a ticket. So it doesn't work that way. You can't say Q therefore P. That only works with biconditionals. So she could buy a prom ticket but then give it to her friend or something. I don't know. But what does matter is that there's no valid conclusion. So Sarah purchases a prom ticket. But maybe she doesn't go to prom. Maybe something happens and she can't go. There you go. That is law of detachment. Once again, the symbols for that were if P then Q, P therefore Q. So the big thing is that those do have to match. It has to be P again right here. Anything. It can't say not P, it can't say Q, it can't say not Q. That's a different law, but it has to look exactly like this to be law of detachment. Okay, so hopefully that makes sense. There you go. Have a good one.